afternoon. There is one question left in 4.5. We were solving logarithmic and exponential equations. You may think, oh, how is this related to logarithms or exponential functions? You will see soon. Let's first review what we did so far in this section so we can learn about our rules, recall our rules. So again, we start with easy exponential equations. We set each side into powers and simplify. And after a while, we learned that sometimes you need to take logarithm of both sides because the numbers are not raising into power of 10, for example. So you need to use logarithms. We used up to here logarithms, and then we started direct logarithmic equations. Easy ones were one side logarithm, the other side simply logarithm. You cross out and solve the equations. But sometimes you may not leave one logarithm on each side because there may be a number right after it, beside it. So we may need to combine logarithms into one and change it into exponential function. That was the last trick we did on Friday. And I was gonna start this question. By the way, this question does not belong to only this section. In 4.6, we will be solving a very similar type of questions. So this is an application of exponential and logarithmic functions. We will use both exponential equations here and logarithms together to solve this. So what is this question about? If you remember 4.2, we built two formulas to compute how much your money deposited grows after T amount of years. First formula was if you are compounding simultaneously, continuously, every split second, your money grows, then you have this formula to be used. But if you wait a little bit, like one day and get your interest, or 1 month you get interest, or quarter you get interest, or year you get interest, there is some time period you need to wait, not continuous, then you must use the second formula. From the wording of the statement, I noticed that my money is growing quarterly. That means I will drop out this equation. We won't use this. It's not continuous compounding here. This is compounded for every 4 months, no, 3 months, every 3 months. So that means 4 times your money will grow in a year, 4 times, because there are 4 quarters, 3 months in a year. And I must be using this formula then, because this is the one using n. N is the number of amounts, how many times your money compounded, and it's 4 in this question. Well, what is really the question? In 4.2, I basically supplied you the initial deposit rate, how many times compounded, and how long you wait. All 4 was given. You just plug them in the exam as well and computed how much money you have after 10 years, okay? Here it's the opposite because you learn new tricks. You can do more about these formulas. They have provided you with the money after I don't know how many years. You wait several years, and this is the money your initial $9,000 grew into. Your $9,000 became $11,000 and some change at 4% interest. Question here is, we don't know how long we're supposed to wait to grow this money to 11,000. Find that T, number of years, okay? And round it to the nearest year, we'll probably get some decimals. So why don't we start with putting down this formula here. It's amount after T years equal to initial amount 1 plus rate offered, how many times you're getting interest in a year, and that n times how long you wait, T, okay? So let's substitute the given quantities. Do we know the final amount our money grows into? Do we? What's the final amount you have in your deposit account? 11,427.65. So this is 11,427.61. Okay, great. Do we know how much we initially deposited? It's, yeah, right? 9K, 9,000. Okay, what else do we know? We know R, right? What is R?
0.04.
Yes, it's not 4. It's 4%. 4% means 4 over 100. 100% means ratio 100. That's 0.04. That's what we're going to enter here. Okay? The rate is 0.04. Okay. What else do we know? Do we know N? N is the number of times you get interest in a year, in 1 year. Since you're getting interest every quarter, 3 months, how many 3 months do you have in 12 months, 1 year? How many? 4. Quarter means 4, right? So that's 4. This is 4. That's 4. Do we know how long we keep this money in this account? No, that's the question. So this is unknown. This is what is asked. This is asked. All right? So this is an equation solving question. Where is the equation? Number, set it into number times 1 plus, all these are all numbers. Look, 1 plus 0.04 over 4. You can compute this. This is a number raised to 4 times the unknown. Your unknown is on the tower, on an exponent. I wish this t was on the floor. I could just divide both sides with these numbers and get t all by itself. It's hanging on the tower like a princess locked in this tower. How do you reach that t? How do you bring it down? Convince her coming down so you can get her. I mean, obtain t. All right? So why don't we first do the simplifications? Let's take a good look at the numbers. 11, 4, 2, 6. No, not 2, 6. 11. Why would you give such a bad number? Give just 11,000, right? Alright. Well, that's quite expected. Sometimes numbers turn ugly in the life as well. Alright. Can we add 1? First, can we divide 0.04 by 4 and add 1 to it? Just take this in a calculator and use it if you want, but isn't 0.04 divided by 4 is 0.01? So these two cancel to 0.01, right? And when I add 1 to it, it's 1.01 raised to n is 4 t. We mark t in red because this is our princess we are trying to reach at, save. Alright, there are monsters around our princess. Again, T is our goal. You need to kill the monster 4, kill this base 101, and kill this 9,000, and get T alone on one side, alone, isolated. So which monster is easy target? Which one can you tackle first one? 9,000, right? This is multiplying my whole bunch of this tower, and on the tower you have 40. But this is like out in the front, defenseless. So why don't we tackle this 9,000 from here? By what weapon? Let's divide. Divide 9,000 both sides. Okay, that's a good one. It's going to cancel this monster, and we'll get one step closer to our target. By the way, what is this? You need to be able to do this in calculator. Eleven 427.61 divided by 9,000, right? that right? Okay, I don't like this. Since it's not terminating, you see 4 is repeating over and over, I will just leave it like that. I mean, if it was terminating, I would change it into decimal. Otherwise, I would make a rounding. If I cut off at 4, the last digit, I will do rounding. And if I round again, I make it too big error. So I will just leave this like that. I won't touch it. Okay, forget what I did. I'm happy with the ratio. That's fine. All right, let's focus on now what we have. Again, on the left, we have this ugly ratio, but I'm okay with that. And on the right, now we have a princess locked in a tower, right on this tower here, and also protected by 4. 4 is guarding the T. Okay, now first, how do you demolish this tower? How this base and this T can land on the ground? What's the right weapon? What's that? Yeah, logarithms bring all the powers to ground, right? If you have an exponential is what I call tower, okay? If you want to wipe off an exponential form to regular form, you need to use logarithm weapon. I'm going to take log of both sides, but what base? Which base would you prefer? Best option is either use ln, base e, or use base 10. So when I just put log without any base, that means it's base 10 again. Alright, do you want to compute this logarithm now? No, I will wait, because if I compute this, it's going to be again a never-ending decimal. I will wait until the final moment to do that. Let's first safely move our princess to ground right here. Remember, when a logarithm and exponential happens, powers goes all the way in front as 4t, 4 and t together. The guard and princess moves together because they're in the power, in the tower. Alright, so again, log of this mess. Again, all this stuff is inside log now. Inside log is 4 times t times log 101. You see, I'm not in a rush to compute any of these logs. I will wait until the last moment and I will punch them into my calculator and compute at once. I will do one rounding rather than I'm doing rounding every time. Okay? Okay, here is your princess. Here is a monster next to it. Here is a giant monster next to it. How do you kill those monsters? Divide again, because they are multiplying my princess, right? So I will divide both sides by not only 4, but also logarithm. So logarithm can cancel as well, because it's multiplying t. I divide and get rid of them. And finally, your princess is saved. How do I know it's saved? It's alone. Look, t is all alone. Do you have anything else besides t? No. But what happens on the left? What do you have on the left? You've been kicking all the monsters to the left. So you have a monster army here, right? 9,000, 11,000, all the logarithm and a bunch of things, all there happening to be computed. They need to be computed. So you need to enter this long expression into calculator and compute. Okay? This is what you need to type in your calculator. Same thing as in Google. Again, logarithm first. Take a big parenthesis. This is the numerator. Numerator as a logarithm of this thing, right? This is numerator. Logarithm of 11,000. If you want, put another extra parenthesis. This is the inside of the logarithm. This first parenthesis is the numerator, divided by a denominator. What is the denominator? 4 log 101. 4 log 101. If you wish, put another parenthesis around 101. Okay? Looks good? If you enter this same syntax, I believe it's going to work in your calculator as well. And what did you get? 999999995. Now it's time to round off. I'm going to round one off, and that's it. 5.99 years is almost 6 years, right? So I will change the symbol. It's not equal. It's approximately equal to 6 years. Okay. Now again, what did I do here? I copied the formula. The formula has 5 letters, unknowns, A, P, R, N, T. To be able to solve an equation, you need to know the first four, and one of them must be missing. Usually A was missing, we found it. Now they provided A, they forgot T. So we solved for T. But T happened to be in the exponent of an exponential expression, a base, 101. So to bring that T ground, you need logarithm weapon, okay? Logarithm force them into the ground. We did that. The rest is algebra. It looks confusing what I did here, but just imagine logarithm like a number. This is a number. If you had here 5, 4 times t times 5, you would divide both sides by 5, right? Logarithm is the same thing. This is a number. I'm dividing both sides by that number. And this is a number as well. All this mess looking thing is actually a number. When you punch in these numbers, you get some decimals. So just treat them like numbers, divide both sides, leave t alone, approximate it, round it off. We got 6. Alright, this is not over. We're going to revisit this kind of question pretty soon, okay? Any questions so far? So you understand right now, because it's coming soon again. Any questions? No? This will complete our homework and start the next one. Which is modeling with exponentials and logarithmic functions. Basically, where do we use exponential and logarithmic functions? That's our topic next. Applications. Well, out of all chapters and sections you learn in this course, logarithms and exponential functions are the most frequently used subjects in real life. So you use them everywhere in chemistry, biology. You'll probably see a lot of logarithm and exponentials in your future courses. Alright? Here is one example. In population estimations, US population estimation, we use logarithms there and exponential functions as well. So as a short-term model, of course all these estimations can be done for short term. You can't estimate what's going to happen 500 years later, okay? Because a virus can pop up and kill all of us, right? We never know. So we just estimate it for the next 10, 20 years. So this is the estimate. Our population will grow from 310. What do you think 310 is? The current population of US population is 310 million. They dropped a million. And it's going to increase at the rate of e to the such a small number. You see how small is this is 0.09 t. Every year you substitute t in the year amount, it's going to move this digit a little bit up. Okay? Like the next year, if you put 1, it's going to be 3,310,500,000, for example. I don't know. Okay? So we need to really put that into calculator. But this is 2010, of course. So if you want to measure current population, you need to put 6. If I put 6 here, we may compare if that number that model is correct. Okay? But what they did here is, usually, this is a common question. How long does it take our population to be 400 million, for example? You're wondering how long is that time frame will be. So you need T solved. T is the number of years needed to reach at the target population. And just like we solved the earlier question, this is your princess. We divide both sides by 310. Look, they divided P by 310 and took a ln logarithm of both sides and got our princess along. You see, same idea. They did the same thing. They saved the princess from this tower. And this is the number of years you need to wait till the population becomes whatever P amount is. If this is 400, you plug in 400 here. To reach at 400 million population, you need to wait this many of years. You just need to enter it. Okay? This is just demonstration of where we use exponential and logarithms. Just like money growing, population grows as well. If you're in biology, you will probably model bacteria growth in your plant. Okay? And trust me, you're going to come up with a formula like this with a different number. This is for population. If your bacteria is growing fast, maybe this is more than 1. Because I know some bacteria doubles, triples every minute. But here's one formula. It says used in chemistry. I don't know where it's used. Probably N is for nitrogen. And you guys use nitrogen for plant feeding, right? And this is probably the nitrogen amount in soil. If you see a negative number here, what do you think? What do you expect to get there? If this is nitrogen, if it's negative number here, it's getting more or less? Less. So again, negative number before time, it means you're losing nitrogen in soil, probably because plant is using it. But what is questionable here is how long, for example, next fertilizer, you're going to apply next fertilizer, but how long you need to wait, for example, for the nitrogen level to drop to half. So I need to solve for T. If anytime they want T, question how long, if you see the word how long, you need to save your princess, guys. T must be brought down, left alone. Okay? Got it? So get T by itself. This is our task here. There is no real question here, only solve for T. Because that's basically what's in done, most applications. Let's start. Just to read, these are our numbers. N and N0 are just two like numbers. And T is on this tower. So you need to get T alone on this side. So I will first attack N0. It's on the ground, and it's the first thing I hit, right? So how do you kill this N0 from this side? N sub 0. Ah. What did I do with 9,000 before? Divide. So I divide both sides by N0 first. Okay? Alright, sounds good. I have N over N0 on the left. You see these are canceling, and I have only e raised to a number many times t. Okay, next, all I'm left with is a tower with princess locked on the top. How do you demolish this tower? E must go away. Yes, we will this time use not log, not regular common log, but I will use ln because it's more convenient to use ln. Why? Because I know what happens if ln and e comes together. What happens to them? ln and e comes together, they cancel to 1. Or they just disappear. So So when I have this, you can do that. And this princess and this monster next to it, if this disappears with my magic, can they hang on the air like that? No, they will drop. They will drop to the ground, okay? So this side is easy, it will fall to ground and make minus 0.025 t. Or if you wish, you can understand this that way. Whenever I have a logarithm, this guy is brought in front. So it is this stuff times ln e, but ln e is, as I said, it's 1. Logarithm base e match becomes 1. So it's still this term. I have a mistake on the left side. What did I forget? Where is the mistake? Yeah. You can't just put ln to one side of the equation. It's not fair. Equations are like balance scales. If you put some weight on this side, you need to put weight on the other side as well. So you need to do it to the both sides. I have an ln. Yes. All right. Solve for, again, means isolate. Do you see your t completely isolated? Do you? Yet? Do you see t all by itself? No. I have this monster waiting, protecting t. So how do you kill that? Divide. You divide only this side? No fair. You divide this side as well. Okay? So, usually we like t on the left. You're actually done here. The question is over. T is solved completely alone. But I like t on the left and messy stuff on the right. T left, that mess on the right. So I will flip these two sides, okay? So t will be equal to over this one. Okay, this should be sufficient, but usually I don't like seeing a fraction, not a fraction, but decimal in the denominator. This is actually a fraction, as I said. It's minus 25 over, how many digits do you have after that? 1, 2, 3. So I put 1, 2, 3 zeros after it. This is actually a fraction. And you know, in math, we don't like fractions in the denominator. Whenever you have a fraction in the denominator, actually go all the way to this side, we flip and do what? Multiply. And I flip and multiply 1,000 over 25. What is 1,000 over 25 actually? It's a whole number. You can put there minus 1,000 over 25. ln n over n0. What is 1,000 divided by 25? 40. 40. Because 100 over 25 is 4. You have an extra 0 there. Minus 40. Look, this looks a lot better than this, isn't it? Except it's not n0. Right? I always do this mistake as well. The ratio is inside ln, not under covering ln. So back up. Just put the ratio under n. Alright, these two are together inside ln. So when you're typing in, be careful where you put your parentheses. Although you did everything right, because of that wrong parentheses, it may say incorrect. So it is minus 40 ln n over n0. How do I? Choose n and right after make a slash. How do I make n sub 0 though? Do you know how to make that n sub 0? This is the option. To make logarithm base as well, you need to make use this. So first put n, choose this to make sub 0. And then go to the right, close parentheses. Should be it. Alright, where's my mistake? Usually a space is a mistake. I'm making mistakes anyway, guys.
You have to have a multiplication between 40 and 11.
I did here. You mean this? Let's check. Unbelievable. For the first time, I agree with you. Connect math sometimes stupid. But yeah, it just likes my earlier answer. Don't change it into. Yeah, they like it like this one. So it's not that smart. They want this as an answer. Okay. So what I did is clean up, brushed up my answer. They don't like the cleanup. Okay. All right. Proceeding next. Any questions? So we have our answers matching. Just make sure you don't do any flip. Just keep it ratio. All right. Same idea. This time the situation is reversed. You no longer have an exponential. You see, no, your princess is not in a tower anymore. But tower was the prison for the earlier princess. Now my princess is this, I. It's locked in a logarithm dungeon, not tower anymore. It's a dungeon. Okay? Logarithm. Different type of prison, let's say. How can I get to I? I need to kill monster I0. I need to kill logarithm prison. I need to kill this number 10. Which one is the easiest target? Who's first? Of course, 10. Get 10 out of our way. There you go. That was a weakling. Let's attack the big monster LOG next. And this is probably for the first time. We're not doing it for the first time. There are multiple ways. I know you guys thinking. Yes, Jay?
Put log on the other side to cancel that.
Yep. We are going to change this logarithm. No, we're not going to put the logarithm on the other side though. We're going to wipe off the logarithm and change it into exponential, but we will put things on the opposite side. So one trick is to use logarithm BAC becomes exponential when you flip these things. So we are going to flip things. Base becomes base. Free guy goes to the tower locked up. Prisoner goes free. Do you remember this trick from 4.2? Reordering terms in logarithm and converting into exponential. That's one trick. That's what the main trick I kind of do. But I know there is an alternative. Do you know the alternative way to kill logarithm? What is the alternative? Hmm? Yeah. We raise both sides. We put both sides, left and right, to the base. Raise to a base of 10. So you put 10 to the both sides, just like that, and put this guy to the top of this 10, and that one to the top of this one. I wonder why Austin chose base 10. Do you know why? Why?
Cancel the line.
Look. A common logarithm, a logarithm with no base, has a secret base 10. And once upon a time, 4.2 or 3, section 4.3, I believe, or 4 maybe, if you have b, logarithm of a base b, a, if these two b match, they match, what happens if they match? They cancel. These two cancel, that means your princess in dungeon, there is no more dungeon. Log is gone. Okay? Log is gone, and these guys will fall to ground. Fall into ground. And how about this? I will go to it, go find it out later, but I have no problem with this. Feel like you can change 1/10 into 0.1, that's what it is. What I see here is my princess is almost safe, except it's guarded by this I sub 0. I want it gone. Why do I like that I 0? Because look, solve for means isolate. You will keep going until you get I by itself. I don't like to see I sub 0. So how do you cancel I sub 0? By the way, I sub 0 is a number. It stands for a number.
Wait, on the left side, is that L over 10 or is it 1?
Oh yeah, thank you. It's my, thanks for fixing that. It's my poor typo. It should be L, right? So it's not 1/10. I said it's 0.1, no. It's L. Yes, thanks. So you cannot compute this, because we don't know what L is. It's a number though, it stands for a number, it will be provided. But it's just a formula so far. Alright, so how do I get to I sub 0? Multiply. Either left or right, multiply both sides by I sub 0. And this what's gonna happen. Cancel, cancel. This will be all remaining, okay? And I like I on the left and this stuff on the right, so I will flip sides, okay? This guy goes left, this guy goes right. So I equals I sub 0, 10, L over 10. Okay? Alright, this time it worked because we didn't simplify nothing. Alright, this was raising to the power 10 method. I told you there is first method, this method possible. This is how you do. Again, this is your C, this is your B, and this is your A in the formula. A is the prisoner, B is the guard, B base, and this is the free guard. When you reorder these, This is the second method. When you reorder them, base becomes the new base. Free guy on the other side becomes the new prisoner in that base. And this old prisoner in this dungeon is set free. Look, did we get the same thing? Yeah, look at this. Is this result, where is it? Here. When you cancel these, you got L over 10. L over 10 equals I over I0, right? Aren't they the same? No, they're not. Because this is 10 raised to 1 over 10, right? They don't cancel. So when I cancel this, I over I0 is what I get here on the left. 10 raised to the power L10. Is it the same? So this is direct conversion to exponential method. And this is raising to power of 10, base 10. Either way is fine. Okay? Any questions? So once they give you the L quantity, I0 quantity, you will know what I will be just converted. All right, let's talk about these two pictures and experiments and stop there for today. So again, there are two modeling you can make using exponentials. One is exponential growth, the other one is decay. All right? Just like bacteria or population is growing, you may have nitrogen level in soil going less and less, decaying. So in both scenarios, either growth or decay, we always use exponential function, especially e. But if there is a growth, we use a positive number next to time. But if it's a decay, quantity is getting less and less over time, and we use negative number, like minus 0.165, positive 0.06. And this one is how much your money is growing at 6% rate over the time. $2,000 become almost $7,000 after 20 years. And same way, this is the cancer rate after treatment. They give you a drug and cancer gets smaller and smaller. And that amount, if it was 100 cells at the beginning, after 20 months, let's say, or days of drug use, it gets to less than 10 cells. All right, so what's the causing the going the down picture? It's this negative number, negative rate. Okay, so these are two demonstrations of applications of exponential growth and decay. We will make our own questions, one for finance, one for population, and I think there is also radioactive decay. This is getting less and less radioactive material in the following questions, okay? This is all due tomorrow.
About 7 minutes.